In part 2 of operations with radicals, we're going to work on multiplying radicals. So all of my multiplying rules apply, specifically the rule of FOIL. So if you remember, FOIL stood for first, outer, inner, last, and the property said that if you have two binomials being multiplied, that you would multiply the first. So you would have A times A. You'd multiply the outer, A times B, and then you'd multiply the inner, B times A, and then also would multiply the last, B times B. So that same idea is going to apply in these multiplying of radicals. The only thing different is you're going to have radicals instead of x's, y's, a's, and b's, but you're still going to FOIL. You're going to FOIL because it'll look like two binomials times each other. So here's my example. I have 2 square root of x plus the square root of y times 6 square root of x plus 2 square root y. So I'm going to do, because I have a binomial times a binomial, I have 2 things times 2 things, I'm going to do FOIL, or some people call it double distribute. So the first thing in FOIL says do the first. So first off, I'm just going to write them down. 2 square root of x times 6 square root of x. And I'm going to do the outer. So I'll have 2 square root of x times 2 square root of y. The inner, square root of y times 6 square root of x, and then the last, which is square root of y times 2 square root of y. So that is everything not multiplied, just written together. Now my multiplying rules say multiply the numbers in front and then multiply the numbers under the radical. So for this first part, 2 square root of x times 6 square root of x, well, I'm going to multiply the 2 and the 6 and get 12. And then I have a property that says if I have 2 things under a radical, I can stick them together under one radical. So then I'll have x times x, which gives me x squared. And I've just stuck them under one radical. So the little step in the middle said the square root of x times the square root of x. I could put them under one house and give me the square root of x squared. I'm going to go through and simplify later. Okay, the second part, 2 times 2 gives me 4, the square root of x times y. Okay, the next one, I have just a 1 out front of that, so I have 1 times 6, which gives me 6, and the square root of x times y. Just flip the order. Instead of y times x, I wrote it as x times y. Commutative property says that you can flip the order over multiplication. And then my last one, I have another 1 in front, so I have 1 times 2, which gives me 2, square root of y squared. Again, that middle step, I stuck them under one radical, and because I could combine up y times y to be y squared, I went ahead and stuck it as y squared. So here is my more simplified version. Now I'm looking for if there are any like terms or if there are any radicals that need to be simplified. So let's look each one. So I have 12 square root of x squared. Well, we learned a few sections ago that the square root and the squared will cancel each other out. So for that one, I will have 12x because the square root and the square undo each other. For the middle one, I have 4 square root of xy plus 6 square root of xy. So because those are like terms, let's make a note. Because those are like terms, I can add 4 and 6, which will give me 10 square root xy. Now the square root of xy can't simplify or anything because it's just an x and just a y, so I'm going to leave it written together and I'll just have a 10 out front. And then my last one, I have the same thing as with the x squared. I have the square root of y squared. Those cancel, so I have 2y. So my final answer is 12x plus 10 square root xy plus 2y. I can't simplify it anymore because there are no more like terms, so that's just where I leave it.